before we get started, are there any questions over the assignment? Number 10. So for number 10 on the assignment from last night, 5x squared minus 18x plus 9, there is no greatest common factor between these three terms. Since the third term is positive, our signs are the same and they match the sign of the middle term. So we're going to have minus and minus. Factors of the first term, we would indeed have x and x. And then 5 and 1 for the factors of 5. Now the factors of 9, we have 1 and 9 or 3 and 3. Which one do we want to try first? 3 and 3. And if we check this here, 5x times negative 3 would be negative 15x. Negative 3 times x would be negative 3x. And negative 15x minus 3x is negative 18x, which is the middle term we wanted. So 5x minus 3 times x minus 3 are the factors. Questions on this here?
Can we also do 11?
No greatest common factor. Since the third term is negative, our signs are opposite. Factors of the first term would be n and n. Now the factors of 4 are 1 and 4, or 2 and 2. Well, we can try 2 and 2 first. And the factors of 25 are 1 and 25 and 5 and 5. We can try 5 and 5. This is definitely not going to work because our 2n times negative 5 would be negative 10n. Our 5 times 2n would be plus 10n, giving us 0. I think the better one to switch would be from 2 and 2 to 4 and 1. 4n times negative 5 would be negative 20n. 5 times n would be plus 5n, giving us negative 15n.
I just had the sign wrong.
Okay. Right, because if you multiply out and get the correct number but wrong signs, flip the signs. Any other questions on these here? What we're doing today and tomorrow, so this section is going to take 2 days mainly because just there's several different types of factoring that we're going to look at. They're more specialized. There's kind of some things that are unique to them. And the first one we're going to look at is this one here, 4x squared minus 4x plus 1. And there is something unique about how this factors. But it still factors the exact same way we've been doing these so far. And if we look at this here, the first thing we should look for is a greatest common factor. So 2 is in common with our 4x squared 4x. But unfortunately, 1 is not divisible by 2. So there, unfortunately, is not a greatest common factor between these three terms. 2 of them, yes, but not all 3. Now, the next thing we look at is signs. The third term is positive, so our signs are the same and match the sign of the middle term, which would be our minus and minus. Next step is look at the factors of the first and third term. So our 4x squared and 1. With 4x squared, we would have x and x, because that's the only way we do get x squared. Now our factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. Now the factors of the third term, factors of 1, well, there's only one set of factors for 1, which would be 1 and 1. Now at this point here, we can check to see if we got the correct arrangement. Now our 2x times negative 1 would be negative 2x. Our negative 1 times 2x would be negative 2x. And our negative 2x minus 2x is negative 4x. Is that the middle term we wanted? Yes. So our set of factors for this here are 2x minus 1 and 2x minus 1. Now what's interesting with this is that, well, the two factors are the exact same, and since they are the same, we can rewrite it as a single set of parentheses squared. So we could say that it's 2x minus 1 times 2x minus 1, or we can just write it as 2x minus 1 squared. Both of these are the correct answer. You don't have to get both, you just need to get one of them. Questions on these here? Now it does work out that when we factor these quadratics and end up with a single set of parentheses being squared, we actually call these perfect square trinomials. Let's look at the next one here. 16b squared minus 40b plus 25. Is there a greatest common factor? Unfortunately, there is not one between all three. So we can do our two sets of parentheses with 3 spaces. All right, guys, let's focus back in. Yes. Now, since the third term is positive, our signs are the same and match the sign of the middle term, which is negative. So we have negative and negative. Now we need to find the factors of the first and third term. Now the factors of our first term, 16b squared. Well, we'd have b and b, and yes, one of the factors of 16 is 4 and 4. But we also have 2 and 8. Which one do we want to try first? Where are we going? 4 and 4. Factors of the third term, factors of 25. There's 2 of them, 1 and 25. 4, 5 and 5. Which one do we want to try first? Do we want to try 1 and 25 or 5 and 5? Now again, at this point here, we can check to see if we got this correct. Our 4b times negative 5 is negative b. Our next one, negative 5 times 4b is negative 20b. Negative 20b minus 20b is negative 40b. So these are the correct set of factors. Now again, because they are the exact same, we could rewrite it as 4b minus 5 squared. Questions on this here? All right, guys. we're going to do this one here. 100x squared plus 180x plus 81. Now for this one here,
I think the ninth grade girls have to the office. The ninth grade girls.
there is no greatest common factor, so we'll have two sets of parentheses with three spaces. Since the third term is positive, our signs are the same and they match the sign of the middle term, which is also positive. So plus and plus. First thing we'll do is find the factors of 100x squared. Well, the factors would be 1 and 100.
25, 4, 15, 2, oh, never mind. You got 5. That's all I got. Oh, yes.
So factors of 100 is 1 and 100, 2 and 50, 4 and 25, 5 and 20, and 10 and 10. Which one of these do we want to try first? 10 and 10.
Can't calculate it like that.
Now factors of 81. Well, we have 1 and 81.
Okay, here's
9 and 9. And 3 and 27. Which one of these do we want to try first?
Let's do 9 and 9.
And here we can check this here. 10x times 9 is 90x, because our 10 times 9 is 90. Then we have 9 times 10x, which would be plus 90x. And 90x plus 90x is 180x.
And we can put that squared.
Yes.
Got it? Ready to move on? Sorry.
Now the next group that we're going to look at is our difference of perfect squares. If we have two terms that are perfect squares and they're being subtracted, so a squared minus b squared, it will factor in the form of a plus b times a minus b. So if we look at this first one here, n squared minus 25, is n squared a perfect square? So we could rewrite it as n squared. It's pretty much the same thing.
I need the ninth grade boys come to the office. The ninth grade boys come to the office.
25. What times itself is 25? So we could say that this is n squared minus 5 squared. And the reason I set this up is more to match it up to the general form. Because what that we're saying here is that our a spot is n, our b is 5. So what this will factor to is n plus 5 times n minus 5.
Have we done this?
Mm-hmm.
I thought we did.
We have.
We're all getting lost, but almost all the time.
Questions on this here? Let's look at the next one here. 16n squared minus 9. Well, what times itself is 16n squared?
4.
Because 4 times 4 would indeed give us 16, and n times n would give us n squared. Now the question is, what times itself is 9? So, our a and b, so it'll tell us that we have 4n plus 3 times, guys, 4n minus 3. Questions on this here? 4m squared minus 25. Does it be 2m? And 25 would be? So this would factor 2m plus 5 times 2m Questions on this here? Now this one here, a to the fourth minus 9, is still a difference of perfect squares. Because if we look at this here, what times itself is 9?
I need all sophomore girls to report to the office. All sophomore girls report to the office.
A squared?
It is a squared. Because a squared times a squared is a to the fourth. Or we can say a squared squared. So this is still going to be the same as the one we had before, but instead of having just a term to the first power, this time we have plus 3 and a squared minus. Because this is the same as what we had before, but instead of putting just 2m in both of these places here, this time we're putting a squared. So it follows the same pattern, but this time we just have a variable to an exponent in each one instead of just to the first power. Now it is possible that one or both of these could factor, but we do not have a set way to factor a sum of perfect squares. So this is as simplified as it gets. Now we do need to make sure the other one is not a difference of perfect squares. A squared is a perfect square, but is 3 a perfect square? What times itself is 3? And it continues on because it's an irrational number. So this is the answer. Questions on this here? Let's look at another one here. K to the fourth minus 36. So we can rewrite this as k squared squared. Now what times itself is 36? Is 6 squared. So how would this factor? K squared plus 6 times k squared minus 6. Now our k squared plus 6 is completely factored, but we do need to make sure our k squared minus 6 is not a difference of perfect squares. Is 6 a perfect square? Questions on these so far? Last one of these that we're going to do, x to the fourth minus 81. Yes.
Yes, sir. See, I did the problem. I got 1 9. So we need 8.
Oh.
So here we're good with getting x squared plus 9, x squared minus 9. Yes.
No. Here's the answer.
So we're good to get it to this point. Yes. X squared plus 9, sum of perfect squares, we don't have.
Please, the sophomore boys come to the office. The sophomore boys come to the office.
But if we look at the other part of this, the x squared minus 9, is it a difference of perfect squares?
Yes.
Yes, it would be.
Yes.
Yes, sir, Kirsten. That's what I'm talking about right now.
There's our x squared minus 9. If we wanted to, I could write it out to the side. Because it'd be our x squared minus 3 squared. So we have our x plus 3 and x minus 3.
X squared plus 9.
It technically doesn't factor. I mean, it does and doesn't. For us to be able to factor, we really need to know the solutions and work back to its factors.
So why x squared plus 9?
Because this is still part of it. It's just that this time, x squared minus 9 is a difference of perfect squares. And that's what gave us the x plus 3 and x minus 3. X squared. Unfortunately, we can't. I mean, we can and we can't. It just works out that for this here, if we did factor it, it would end up being x plus 3i and x minus 3i. But to be able to get that, we'd need to know the solutions of it to work back to it.
Okay, so we're going to get the one that's minus.
Yes, because we do have a formula for difference of perfect squares. It does factor, but a sum of perfect squares does not.
Where did we get the iPhone?
Well, it is possible to factor this, but to factor it, we need to know the solutions.
Oh, okay. Do I write that?
No. Because here, it would almost be we set it equal to 0, solve for x. When we solve for x, we find out that x is equal to plus or minus 3i. Set it as 2 separate statements, solve for that, and go back to it. But this is the final answer. Yeah.
That's true. Because I knew what she was saying. I knew what he was saying, but Kirsten didn't.
So we don't have to do that part. So the x squared plus 9 times x plus 3 times x minus 3 is the final answer. Questions on this here? All right, guys. This is the next thing that we're going to do. Sum and difference of perfect cubes. Now, there's 2 set patterns for the sum and difference of perfect cubes. And one of them for the sum of 2 cubes is a plus b times a squared minus ab plus b squared. For the difference of 2 cubes, we have a minus b times a squared plus ab plus b squared. And this pattern works every single time. Now, one of the 2 things that we're going to highlight is the signs. For the sum of 2 cubes, we're adding 2 perfect cubes, 2 terms that can be multiplied by themselves 3 times together. And when we add them together, the signs are the same. First sign is the same. Second sign is opposite. And it always ends on a positive note. If we look at our difference, where we're starting off with subtraction, the first sign is the same. Second sign is opposite. And the third sign always ends on a positive note. So just looking at the signs, it's always going to be the same, opposite, always ending on a positive note. Our variables, we have a, and then the bigger one we have a squared, a to the first, and no a term. Our other one we have b, b to the first, b squared. Now, we do have these general forms. It's going to make a little more sense when we actually put some numbers to them and work these out. Now, the first thing we're going to look at is if we're given two terms, addition or subtraction, and especially if we have an x to the third, is to see if this is a sum or difference of perfect cubes. And to do that, we're going to take the cubed root of both.
We are now ready.
All right, guys, we can talk about those in a little bit. Let's finish up this problem here. We'll finish the note sheets tomorrow. So this here is the last problem we're looking at. Now, the first thing we need to do is make sure that the two terms that are given are perfect cubes, that they can be multiplied by themselves 3 times. And to do that, we can just take the cubed root. Now, the cubed root of x to the third is, well, just x. Because whenever the exponent and the root are the same, they cancel each other out. Now, the cubed root of 125, we can do that in a calculator. We can do 3 second cubed root of 125 is 5. So that tells us the cubed root of 125 is 5. So this is the sum of two cubes. So when we factor this, for sum and difference of perfect cubes, we will still have 2 sets of parentheses. The first is going to have 3 spots, 2 terms and a sign. The second is going to have 5 spots, 2 signs, and 3 terms. Now, the first thing we're going to look at is signs. The signs are always going to follow the same pattern. There's going to be the same, opposite, always end on a positive note.
We are now ready for the senior boys to come to the office. The senior boys to come to the office.
So same, opposite, always end on a positive note. So since our starting one is plus, for them to be the same, our first sign is going to be plus. The next one is going to be opposite, so the opposite of our plus is minus, guys. And we're always going to end this on a positive note. So our last sign will always be plus. So, guys, since we're talking about a sum of two cubes, same, opposite, always end on a positive note, will be plus, minus, plus. Now the next thing we're going to do is we're going to put our first term in, which is our cubed root of x to the third, which would be x. Now inside the bigger one, we're going to be descending in powers. The first one is always going to be that first term squared. In the middle, we'll have that term to the first, so x to the first. And we won't have a x term, or that first term, in the third spot. Questions on this so far? Our other term, which is our 5. In our first set of parentheses, it's just going to be 5. In the bigger one, we won't have a 5 term in this first spot. In the middle, it's going to be 5 to the first. And our last spot is going to be 5 squared. Questions on this here? So our first spot is going squared, first, not there. Our other term is going 0, 1, 2. The powers of one are decreasing, and the other is increasing. Now the last thing we need to do is just simplify this down. The x plus 5 will stay x plus 5. Now the other one, the first thing we're going to do is our x squared, which actually is just x squared, minus our middle term would be x times 5, which is 5x, plus 5 squared is 25. And that's it. Now we will finish these note sheets too.